Welcome to AskPrep, your trusted companion for NEET and JEE preparation. Today we will study about a very important topic of physics, which is communication systems and the basics of modulation. From mobile phones to radio transmissions, communication systems form the backbone of how information is transmitted across vast distances. Communication is the process of transmitting information from one place to another. This can be done through sound, light, or electromagnetic waves. However, transmitting signals over long distances comes with challenges such as interference, signal degradation, and noise. To overcome these challenges, modulation is used. Modulation is the process of altering a signal to make it suitable for transmission. When raw signals, such as a person's voice or a piece of data, are transmitted directly, they tend to weaken and distort due to interference from other signals. Modulation helps in improving the quality and efficiency of signal transmission. A communication system typically consists of three main components: a transmitter, a communication channel, and a receiver. The transmitter converts the original message into a signal suitable for transmission. The channel, which can be wires, optical fibers, or even air, carries the signal to its destination. Finally, the receiver extracts and reconstructs the message from the signal. In everyday life, we see numerous applications of modulation. In radio broadcasting, modulation allows sound signals to be transmitted over long distances by embedding them into carrier waves. In television, modulation is used to transmit both audio and video signals efficiently. Mobile networks also rely on modulation techniques to send voice and data signals between users. Without modulation, long-distance communication would be impossible. Whether it's a phone call, a satellite transmission, or even an internet signal, modulation ensures that the information reaches its destination clearly and efficiently. In simple terms, modulation is a technique that alters a carrier wave to embed the original message. This carrier wave, usually a high-frequency wave, helps the signal travel efficiently over long distances. Without modulation, transmitting signals effectively through air or cables would not be possible. Communication systems rely on modulation in almost every aspect of modern life. Take, for example, radio broadcasting, where sound signals are modulated onto electromagnetic waves so they can travel vast distances. Television signals use modulation to combine video and audio signals for clear reception. Mobile networks employ modulation techniques to send voice and data between users without interference. Even satellite communications depend on modulation to relay signals between ground stations and satellites orbiting the Earth. Amplitude modulation, or AM, is a technique where the amplitude of the carrier wave varies in accordance with the message signal while keeping frequency and phase constant. AM is widely used in radio broadcasting and two-way radio communication, but it is susceptible to noise and signal degradation. Frequency modulation, or FM, involves varying the frequency of the carrier wave according to the message signal while keeping amplitude and phase unchanged. FM provides better noise resistance compared to AM, making it ideal for high-fidelity audio transmission, such as FM radio and television audio signals. Phase modulation, or PM, is where the phase of the carrier wave is altered according to the message signal. It is closely related to frequency modulation and is widely used in modern digital communication systems, particularly in wireless networks and satellite communication. With advancements in technology, digital modulation has become dominant in modern communication systems. Digital modulation techniques convert analog signals into binary data, which can be efficiently transmitted and decoded with minimal error. Some common digital modulation techniques include amplitude shift keying, ASK, frequency shift keying, FSK, and phase shift keying, PSK. Amplitude shift keying, or ASK, transmits digital data by varying the amplitude of the carrier wave. When the signal is high, 1, the amplitude is present, and when the signal is low, 0, the amplitude is absent. ASK is simple but highly susceptible to noise and is used in applications like optical fiber communication and RFID systems. Frequency shift keying, or FSK, encodes digital data by shifting the frequency of the carrier wave. A higher frequency represents binary 1, while a lower frequency represents binary 0. FSK is more resistant to noise than ASK and is commonly used in low data rate wireless communication systems such as radio telemetry. Phase shift keying, or PSK, changes the phase of the carrier wave to represent digital data. A common form of PSK is binary phase shift keying, BPSK, where the phase shifts between two values to represent binary 0 and 1. More advanced versions, like quadrature phase shift keying, QPSK, and quadrature amplitude modulation, QAM, allow for higher data transmission rates by encoding multiple bits per symbol. These techniques are widely used in satellite communication, Wi-Fi networks, and cellular technology. The choice of modulation technique depends on the application, the required data rate, and the communication medium. For example, AM is still used for long-range radio broadcasts, while FM dominates audio transmission due to its superior quality. Digital modulation methods, on the other hand, are crucial for modern wireless communication, ensuring efficient data transmission with minimal interference. Imagine a world without modulation. Mobile calls would be full of static, television signals would be unclear, and internet connections would be slow and unreliable. Thanks to modulation, we can enjoy seamless communication in every aspect of our daily lives. As we conclude today's discussion, remember that communication systems and modulation are essential in every aspect of modern technology. From simple radio signals to complex satellite networks, they keep us connected to the world around us. Thank you. Keep learning, stay curious, and continue your journey of mastering physics with AskPrep. Best of luck with your NEET preparation, and see you in the next video.